Yeah. Hello, everyone. Welcome to Nonstop Webinars. This is a knowledge sharing initiative by Nonstop IO aimed at building a contextually aware and responsible technology community of engineers, designers, and tech leaders. First things first, apologies to everyone who had registered for the event a couple of weeks ago. We had to reschedule due to certain unplanned circumstances at our end. Quick introductions. I'm Sumit More, co-founder at Nonstop Biotechnologies. We are a bespoke software engineering studio based out of Pune, India. We focus on designing, building, and scaling technology products in web, mobile, and applied AI. Today, I'm accompanied by Dr. Niyati Chhaya, a senior AI research scientist, educationist, entrepreneur, and advisor by profession. Along with that long list of responsibilities, Niyati is also board of advisors at Nonstop IO. Welcome, Niyati. Do you want to say a bit about yourself?
Sure, thanks for that. I think you already introduced me, but essentially I've been industry AI ML researcher for about a little over 10 years now, and I also teach. So that's where the education is comes in. Um, I I believe that making sure that all the cool technologies, the faster they get into products, the more useful they are to humankind, and that's kind of the role I'm playing with nonstop, advising them on how they can take ML into practice. Go ahead.
Thanks, Niyati. Yeah. So a quick housekeeping items and rules of engagement. If you have any questions, please feel free to use the chat box. You can send the questions throughout the webinar. We'll pick the questions as per the availability of time at the end of the webinar. If your questions don't get answered by the end of the event, we'll make a sincere attempt to answer them via a personal email or a public blog post. Yeah. Okay. So today we intend to talk on a topic that is not very often discussed in our journey as technology professionals. The topic is that of ethics in software engineering, and specifically ethics while building applied AI solutions, right? So ethics at its core is defined as something which seeks to resolve questions of human morality by defining concepts such as right and wrong, good and evil, vice and virtue, etc. It tries to define what is the right thing to do, how to do it, and how to stick to doing the right things always, right? In software engineering, ethics is about making conscious decisions that kind of respect the user privacy, promote fairness, and benefit the society. It involves adhering to professional codes, navigating through ethical dilemmas, and understanding the impact of unethical practices. So, as a software engineer, it should be one's aspiration to contribute to the society and human well being, avoiding harm to the humankind, and being honest and trustworthy while building whatever you are building as a technology platform, right? Niyati, anything to add here, maybe with a few examples?
Yeah, maybe I'll give a flavor as to what it means in the context of what we are trying to talk about today, right? So we are talking about ethics in AI or applied AI and ML. The idea here is that how can we take the benefits or how can we reap the most benefits of AI while reducing the risks and adverse outcomes. So we don't want our technologies, models, services, products, any of them harming an individual in any which way. Now, that individual or that entity might be the corporation or the organization that is creating that content, or it might be any other stakeholder in the spectrum of consumers, partners, whatever, learners, all of that. So, what we are going to try to address throughout is take examples and maybe actually just not even cover maybe less than 10% of what this space is. So, ethics is huge. 1 hour doesn't do justice to it. So, we'll try and look at bits and pieces here, mostly with the goal of trying to explain that there is an impact if one doesn't consider these aspects of kind of human well-being while trying to build these models or services, mostly because there's a lack of transparency, and all of these services rely on data that they are trained on. So how do we try to mitigate those risks? What are the potential risks? And maybe we'll talk about a couple of specific aspects of ethics as we go along. Go ahead,
Yeah,
Sumit.
makes sense. Okay. Uh, so software engineering in general and AI ML engineering specifically works closely with a lot of confidential data, right? So Niyati, could you help us kind of identify and define what is it, how is it classified, why is it important, and most importantly, why should software engineers care about it?
Sure, sure. So first thing, any data-driven kind of module or a model or a software or a service that we build is going to be built on any data that a customer is giving or has shared with any entity. Now, the kind of data that we share online is pretty much everything, right? So it might be something that is called as personally identifiable information, which is these things such as say social security number or Aadhaar card number or your name, birth date, address put together, some other specific details from your health records, any of that, when put together, especially in an aggregate, will be able to trace back to that particular individual. And that is known as PII, or personally identifiable information. That is one of the highest level of privacy breach if PII is leaked. In fact, most cyber attacks try to capture PII through various um, kind of attacks that they create. There are compliances that all of us we build our software against, or those, or rather, we need those certifications before we get our softwares into product. PII needs to be handled at that point. What it means is that you should not use or share someone else's personally identifiable information in your workflows, in your data, or you should store it securely, ensuring that you are not leaking someone's identity. You may have heard of kind of compliance related guidances or requirements which are known as the GDPR or other rules, and PII stands out everywhere. Now, PII is a large way of bucketing this information. The It is a subset of personal information that may identify an individual. Now, within this, within or along with this, there are other things such as something that may be sensitive information. So, someone's religious preferences, someone's political preferences, uh, other kind of soft orientations or cultural orientations are usually bucketed as sensitive information. So these harm the human not only kind of directly, but they usually end up hurting the human at an emotional or a mental health or mental state. And that again is information you don't want to publicly release in your UI or in your user workflows. Uh, Now, when we look at domain specific things, so let's say if I take healthcare related softwares or healthcare related solutions, I will be privy to protected health information. And I may be an insurance company, I may be a healthcare provider or a hospital, or I may be someone who's bridging those services or just managing data for people who host those softwares. Protected health information is health related information that an individual shares, trustedly shares with service providers in the healthcare space, but it is expected that that will not be shared out in any which way. Similar to health, there is information on the finance side. So all of us share certain information with our banks. Our banks are aware about the kind of money that comes into our accounts, that goes out from our accounts, there are account numbers, the kind of investments that we do. And obviously, this is on top of any personally identifiable information that they hold. But finance information can be, if leaked, can actually lead to, again, people just taking out money from several accounts, people just kind of targeting you because of your certain profile, be it finance or health, and you don't want that happening. So these categorizations have been actually initiated by policymakers or people who create these compliance related definitions. So the healthcare one came from a policymaker who focuses on healthcare related consumers or healthcare related services. Similarly, finance came from somewhere else. And some of these are also geo-specific definitions. So, for example, GDPR is, while it is globally accepted and globally recommended, to get any of your software out there in the Europe or EMEA side of things, you need to comply to GDPR. So those kind of compliance related requirements are actually tied to these kind of classification when it comes to any personal information that you are using either to train your model or even to simply just store and surface on the UI or for any kind of reporting or analytics. So this is, and it is important for any practitioner to know that mitigation techniques or being aware of if their tool or if their processes have access to any of this information, they need to mobilize or they need to explicitly deal with that information before it is stored or on how it is stored and then eventually how it is used. And we'll talk about a few of those things in a little bit again.
Right, right. Thanks. Okay. So probably like everyone knows, at the dawn of this current decade, something extraordinary happened, right? It was sort of an eventuality that was realized after decades of curiosity, rigorous exploration, and pushing the limits of human intelligence past its previous threshold. So on 11th of June 2020, a company called OpenAI announced release of GPT-3 and made it available for general use via OpenAI APIs. This sort of significantly changed the world as we knew it in the technology space and ushered in a new era of possibilities regarding what technology could build in the real world. So, Niyati, with that as a context, probably we would want you to talk a bit about history and relevance of AI in technology, advent of OpenAI, and its corresponding implications that it brought with it.
Sure. So maybe I'll give a couple of lines introduction of what this whole GPT thing is about, right? So all of us know there is Chat GPT, there is GPT-4, there is DALI 3, there are a few hundred other things that are released every day. They are called language models. These things are trained to learn language and understand language. Now, if you have read enough, right now Chat GPT is GPT 3.5 and 4. What was done in 2020 is GPT-3, which was again a significant jump from some GPT-2 that existed. This whole notion that a neural model, the underlying model or the architecture is called a neural network. And a neural network, the reason it's called a neural network is it tries to mimic the human brain. So this notion that a neural network can start learning and decoding language. So all of these things, any language model is actually a decoder. The idea is that this thing is trained on language that exists out there and it learns to mimic that language. It learns to answer questions. Uh, what that suddenly did is that, and actually GPT-3 did not work well. The 2022 one has suddenly started doing a good job, and 3 did not. But the whole premise that these guys were able to establish and are able to establish today is that now I have both the data and the compute ability to train such machine learning models or neural networks on everything that is out there. Then I can use complicated maths to start teaching this model to behave like humans. And that is what people call reinforcement learning based feedback and other complex terms and things like that. The whole idea is that I have a model which can learn all the data that's out there and it will start mimicking humans. But that becomes a challenge when we actually start worrying about, am I going to harm an individual if my machine suddenly starts mimicking and copying human behavior as it has existed so far. One thing is very noticeable, and all of you would have seen both news articles as well as probably played around with these things, is the fact that these machines are actually well trained on the data that exists. Now, it's what data? It is the digital data on the web that exists. So it only represents people, content, topic, biases that are about the data that exists on the web. And that is actually fairly concerning, right? I don't want, let's say I'm trying to get an answer about certain geo-specific behavior, and all of this was trained only on North America, or all of this was trained only on Japan. It's not going to be relevant in my context of India. Or if I was trying to train for certain demography, which is say age, race, culture, any of that, education, and the data did not exist in these models, when the models try mimicking what is out there, they will fail. It's not that technology hasn't come to a point that we can balance these things out, but by default, they will go back to the things they have learned on. Whether they copy or not, they will, like human beings, try to recollect from memory and come up with things that they understand. And so while this thing is a big deal, both OpenAI actually first came up with DALI before earlier last year, before they actually released GPT 3.5. DALI is saying, give me text and I'll give you images. GPT 3.5 is saying, give me any text, or ChatGPT is saying, give me any text and I'll respond to you. Now, both of these things are generative technologies. The idea behind generative technologies means that I'm not going to retrieve, or I'm not going to do search and return anything that was factually correct. I will make up things based on what I have learned. So now this notion combined that these models are learned only on the data that they have seen, as well as the fact that they are making up things, as against historically where the best thing was Google search, where it was searching from available data and attributing back to some fact, is a big kind of inflection point, both in the availability of technology, but it's an inflection point also in the availability of issues it may correct, kind of issues it may lead to, and bias or information exploiting is both kind of in this context. So, and that's why ethics becomes even more important right now, actually.
Right, right. So you talked about bias. Could you explain what bias is?
Yeah, absolutely. So bias is nothing but a skew towards something, right? So bias actually comes, the idea of bias comes basically from the notion of statistics and probability, that everything will not have equal weightage. Something will have a kind of a skew to one side. And you can have various kinds of biases. I think, Sumit, there's a slide on types of biases, if I'm right. So the essentially what these types of biases talk about is biases that may be introduced because of different behavior of different kind of interventions or different availability of information throughout the pipeline of either the model or the data or the workflow that you have kind of putting together. So an example of a typical bias that we see both in machine learning models or language models, or actually in humans, is known as stereotypes or prejudice bias, right? What that is doing, and this typically is usually to do with gender or race, race or basically ethnicity, right? So and while maybe even simple things like saying a South Indian makes better dosa than a North Indian is actually a prejudice bias. And it's not that it doesn't have some weight or meat in it, but a system trying to start saying those kind of things is tricky because it's not always correct. It is more of an opinion. It is opinion based on some representation of data or information that is available to these machines or to humankind. Similarly, these things actually amplify when it means things like, let's say I'm chatting with someone and I say, hey, I am a doctor, and my, let's say my chatbot response is saying, uh, oh, so responds to me assuming I am a male. And if I suddenly said I am a nurse, and the chatbot responds saying I'm a female, and this happens, and this is not something that I'm making up. And in fact, I think we can talk about some what do you say, some studies where it was proven that multimodal or even models which are learning image and text together start looking at these biases when they come to gender bias. Another example that unfortunately comes up when we look at these language models is he is a manager and she is an assistant, which definitely is not the case always. But somehow, based on some historic data or based on the only data that that model has learned, it may look at those kind of prejudices. Now, a stereotype is something where you have a slant to one side. There actually may be cases where you don't have any notion of one kind or one class or one type of information, and that is known as exclusion bias. So, what that is saying is that my machine has no clue of things that exist. It only knows one or a small set of things. The other things that it has left out, it says it doesn't even exist. And again, this is very typical. You can relate back to, say, humans, where let's say I'm talking to some individual who is sitting in somewhere in Central America, not exposed to everything that's going on in the world, may have an exclusion bias of the kind of food Indians eat. It's as simple as that. And I'm just making this example, but this may happen in localities as well, just because of your unawareness or ignorance. Again, as humans, it may be okay in certain social settings, may not be okay in certain social settings. But as machines or as solutions that we are trying to create for the general public everywhere, it's not okay for our models to do these kind of biases thing. Then you have, so there are terms like algorithm bias, measurement bias, or sample bias, or selection bias. All of those are actually a representation of the data that these models will be trained on, and simply in terms of numbers. So these are actually ideas that are taken from statistics, which are saying based on what I'm measuring, the way I'm measuring things will create a bias in the weights or in the errors or in kind of the implications that I learn, and that's what is a measurement bias. Finally, there is the way we have, human mankind have a notion of memory, which is ability to recall, typically most of us preferring recency. Similarly, models tend to do create a recall bias, which is their inability to maybe figure out old stuff if they are not trained well. So all of lot of these things, in fact, can be handled by the right data as well as like right training mechanisms, and most of the APIs all of us are using have tried to tackle this. However, the prejudice or the kind of stereotype related biases are not something that one can test for always. So there is a need to kind of create solution pipelines, and there are various ways of doing that, and I'll actually address some of those in a little bit. But assuming that a good big organization who has put out a model or a solution is going to solve for everything is not a good idea. One should test for your own use case, for your own application, and for your own customers. Is and looking through this lens of, am I being biased against my customer or my customer profile when doing your tests? And that is something you should always keep in mind when you are creating the test automation test data as well.
Right, right. So Niyati, that makes me think like, our bias is always bad.
No, not necessarily. If I'm creating something which is focused on a geography, let's say I'm creating a chatbot for farmers and I'm training it on vernacular language data as well as the jargon or the way of sentence creation over there. I want my chatbot or I want my systems to actually speak that farmer's language. That farmer is not going to respond to me if I started talking to him or her like a software professional. I have to go down to that person and talk to them like that. So and I gave kind of a very non-tech friendly, or very few farmers potentially use technology right now, but typically this comes up when you are building things for any specific or narrow demography, geography, persona from a customer point of view. Your systems should actually be for them, right? Your solutions, workflows, as well as in fact UI should be for them. So I, or a very simple example that several people point out to researchers or academicians is that don't show us experiments, show us what business ROI am I improving. So it is the bias of that poor researcher to show experiment heavy slides. But usually the idea is that your audience is a product manager or a director or a VP somewhere who's worried about the money, so you need to show them the money. And it's while it is not a typical bias example, the idea, all I'm trying to say is that you have to do it for the customer. So if you have data for your customer and your model starts learning that slant or that skew or that bias, it's a very good thing.
Right. Yeah, makes sense. Probably we should also talk a bit about consent. Like what does it mean and how does it impact AI ML engineering?
Yeah, so consent is a little bit. So let me first bridge why suddenly from bias to consent, right? Now, when we started talking about bias, we said we are going to use someone's data to train our model, or we are going to not use someone's data to train our model. Now, in order to even say that, one needs to, from an ethics point of view, make sure that the customer whose data you are going to use to train is aware that their data is going to be used by some machine or some model or some human. And that is what is consent. Now, consent, again, if we go back to the data types that we talked about, so PII, PSI, or just personal information or aggregated information, anything that is kind of some information that belongs to someone and is going to be used by a machine to build something on top of it or to learn those patterns, that's where we ask user for consent. From a user UI perspective or a user interface perspective, um, based on how that organization's kind of values, rules, and the product itself is defined, either consent is opt-in, which is the case large number of times. And in fact, I think certain GDPR clauses require you to have an opt-in clause. The idea behind opt-in is that first time you log in and you want your system or you are starting to access a AI system or your system is starting to collect that user's data, be it the usage and analytics data or the actual data of the customer, one needs to show a consent screen. The language in the consent screen kind of tells the customer that going forward, your data, whatever form it may be, whatever use case it may be, will be used or stored by the system and may or may not be kind of used for further processing. Again, depends upon your use case and how your product is or service is organized. The second is, let's say I'm a company who says I am most forward-looking AI, only data-driven, learning everything from scratch always. In those cases, the assumption at the first login screen is usually saying any data will always be used. So in those cases, the customer is actually always should be always be given an option to opt out of their data being used. So there is opt-in and there is opt-out. Now, these things are not blanket to all customers. So typically, again, these things are usually specific to verticals and organizations, both creators as well as consumers. But there are types of users that every organization usually ends up defining. So you'll have type 1, type 2, or maybe type 3, where what that range starts qualifying that even if you have given consent, PII will never be used. Doesn't matter. There is, because if you are a GDPR compliant software, PII will never be used. Just doesn't matter whether there is consent or not. Similarly, there are clauses around certain kinds of unstructured or document related information or image related information. It should not be viewed by humans, even by developing systems or even by testing, but it can be viewed by machines, which is algorithms can read and write, or algorithms can store them, or kind of workflows can show them, but human cannot be ever in the loop. So that is in fact a very large volume of data that comes in for any large data driven software or enterprise services. Finally, then there will be clauses that which is typically an opt-out kind of a thing, where or PII kind of a thing, that no machine or no human will use it. What that leads to is that your models cannot even learn features out of them. Your models cannot even test on those things. And it actually impacts the quality of AI that you're building or riding on top of. Last thing I'll address here is that I was talking about human and machine reading content. There is also a notion of duration for which one can store customers' data. And again, there are these very well defined rules in compliance related documents and guidelines, which are required by softwares before they release. The way there are SOC 1 and SOC 2 requirements from a security perspective, they say if you're hosting something as a SaaS product, there will be some requirements. If you're dealing with finance data, there will be some security requirements. The way those requirements on the software and security side are defined, similarly, requirements on purging data, even if the customer has given consent, throwing away that data or purging that data from any product or any enterprise storage beyond, say, 30 days, 60 days, 15 days, whatever be the right mapping over there is required. Again, the way it impacts you or me or anyone doing AI, when you say purge, you purge completely. What that means, you cannot use a 30-day-old model going forward. So you have to retrain, which from a software engineering point of view is extra work and which is okay. Maybe one last thing on this one is usually again based on organizations' beliefs and values. There is some, and obviously their agreements with their customers. Usually you cannot train on cross customer data. So let's say I have a system that creates marketing campaigns for other companies. Technically, I cannot train Nike's model on Adidas data. Or it will be a blunder, right? If I am training on competitors' data, there is a problem. So even those guardrails of ensuring that at the potential cost of not having enough data for training, you have to be true to whatever guidelines are required by compliance agencies, by your organization's values, or by your customer, as well as by your use case, are followed. It's a pain, but it needs to be done. So that's kind of a little bit about consent there.
Makes sense. Makes sense. So that just makes me wonder, like, what are the possible implications if, while engineering, we are not taking these things into consideration, bias, consent, being cognizant about PII, and so on.
I think one of the most recent example is the day Google released Bard. It made a factual error. So actually, the example GIF or a video that they had published was about what should I tell my 9-year-old about, I think, inventions by the Space Center or some such question. It made a mistake there. The mistake was that it said that that particular entity was responsible for taking the first picture of a planet outside our solar system, which was actually not the case. And that information has been published by NASA. So it's not that Google was not trained on that information. It's not that, or rather, Bard was not trained on that information, and Google has that information. Now, fine, it led to a lot of memes and whatnot, and there have been several such blunders along the way. But the direct revenue impact it had was, if I'm right, somewhere over $100 million loss within the next few hours. I think 7 to 8% drop in stock exchange. So, I mean, it's not a good thing, right? I mean, forget about how we impact and lose customers, but here you are doing harm to your own organization. The example I gave is a little bit of an extreme where it is in fact a disruptive technology that was released. And while I wouldn't take away the fact that it was a blunder, fine, one can give benefit of doubt saying it's generative technology and things like that. But impact can be small. It's not that impact will always be huge and grave. But impact can be very, very, very small too, right? So if you have let's say I'll tell you a very simple thing. Let's say I am a accounting tool or something, and it has some AI or some basic logic somewhere. And every time the accountant does a roundup to the number above or below the decimal point, and your AI or a workflow, it may not even be too much AI, right? It's just basic workflow, and we are allowing human to intervene, and we are letting that accountant do that change. And let's say this is any money that is coming in, the accountant needs to approve what is the amount of money that is received. And when they look at say 10.5 rupees, it will always convert, the guy will convert to 10 to make his summation easy or to make his verification easy. If he does that for 10,000 such examples, the loss he is creating is huge, and the discount he is giving his vendor is even huger, right? So this is an aggregated impact of some small thing human is doing in the loop, and AI being very considerate, AI or say software being very considerate to human being the great power, is allowing it. So in this case, what do you do, right? I mean, it's a simple logic thing, and there is, what do you do? I can't go and tell the accountant you can't go change the numbers, because it's the human who is always going to control. Usually, the way of creating a responsible, so the term that is used to start quantifying and exposing the impact is called responsible AI or responsible software. The way of trying to show this fact that I can responsibly use such automation would be to start surfacing reports, let's say every fortnight or every monthly, saying because of this small adjustment that is done, there is an impact, and probably escalated to that accountant's boss or some such thing, right? So this is small aggregated non-AI kind of impact. When it bloats up, one unfortunately people actually start assuming the AI agent or the generative AI or the piece of software that they're working with is actually they're a real human or a decision maker. So it can lead to harmful behaviors done to oneself or people around them just because of some emotion or some information that is triggered by generative AI, and we don't want to do that. Where it's just that if our softwares are not transparent, you do it irresponsibly. So that's kind of how I would quantify impact in a little bit. Mayur, we'll come back to your question in a little bit.
Okay. Uh, yeah, so just building on top of that, recently at one of the tech events in Pune, we were brainstorming on this question of do we have any sort of gold standards when it comes to defining bias, consent, etc. Sort of a rule book for do's and don'ts while engineering AI ML solutions. To which the answer was not very convincing when we kind of talked. So basically, it came boiled down to that there are no gold standards or nothing of that sort. So, do you want to talk about little on ethics related initiatives that are currently going on, which could answer these questions?
Sure. So I think you're right. There is no one standard. Unfortunately, there isn't kind of a rule book yet, mostly because of the changes that we are seeing and the pace at which these models are both adapting, learning, as well as the various, I would say, loopholes that are being exposed along the way. But there are a few ground rules that one we or the other, everyone collectively is trying to follow here. What people are trying to say is that a good way to measure or a good way to start qualifying your softwares and systems is to ensure that there is transparency, there is fairness, there is accountability, privacy is handled, and human is not harmed at a very high level. And how do we start doing that, right? So you do this like any due diligence process. So uh, as a joke, I would say that the way one does due diligence in finding a partner to get married to, or doing due diligence to find do your legal things, or due diligence to find financial things, here there'll be similar due diligence. what that actually means is that you will try to diagnose and audit anything that is happening, or you will try to measure, or you will try to just improve the data that you are giving it, right? So it's just start representing everything that you want your outcome to have. Now, how this is all theory. How is it being done in practice? Is it being done in practice at all? So there are a few initiatives. Actually, one is there are ethics guidelines that are being now published by organizations like UNESCO. Uh, there is something also known as the FATE framework, again going back to fairness, accountability, transparency, and ethics, where there are some guidelines that are built on these four motions. Then there is, in fact, the IEEE Global Initiative, which is kind of known as Ethics of Autonomous and Intelligent Systems. So this is very focused on these LLMs and autonomous agents. And what they are trying to do is to try to quantify what transparency and accountability looks in these LLM spaces. Then a little bit more, say, advanced or a little bit more structured is something known as a review board that Stanford has set up a few months ago. Again, so the people on the review board are leaders in the space of AI, people who are creating this AI and the models underneath, as well as the industry who's kind of using it. Finally, on the image side, remember, image generation is a little more advanced than this ChatGPT thing, about a year, and it is way more harmful than one messing up language. Like, if I don't know if any of you actually Midjourney and Dali, or for that example Firefly, all of those things are completely generative text to image models. uh, what that means, it can generate anything. So there is a need to identify. So there are a few things here, right? So one is there is a need to make sure that the artist or the creative who in the earlier was a human being is not harmed, and to ensure that provenance, uh, as well as kind of transparency on how that content is created. There is a content authenticity initiative, again run by pretty much all the big organizations who have created these image to text models. Adobe being one, Microsoft being another, and now there are like probably another 15 who have bought into it. So it's a fairly large board. Uh, Similar initiatives are being tried on the tech side, but it is harder. But the idea is that I will start attributing automatically generated content to models. But any content which starts mimicking, let's say, an artist completely, the word there is actually called to mimic, or to, it's trying to retrieve instead of generate, is I will start saying that this looks like someone else's art. And the way if I copied from Sumit in an exam, I will be punished. Similarly, these models are punished programmatically if they start copying some human art. And they are used in both ways. There's a degree of copying and all of that. And Mayur, to your question on that, Mayur's question is, can we get trademark on logo generated using AI platforms like Midjourney or Ideogram? I don't exactly know from a legal perspective if a trademark, as to why a trademark cannot be obtained. Typical legal due diligence when a trademark is filed are on the design aspects, dimensions, logos, the proximity of that trademark to some other trademark, and all of it. So as long as those aspects are fairly diverse, this particular design is as good as someone sketching it and then using some AI help to make it better. So yes, from that perspective, it can be obtained. However, you can't say that this trademark was designed by an individual. You will have to give in that watermark or that signature saying it was generated by Midjourney or Dali or whatever. So when you fill in the form, it will be that the designer or the creator of the trademark is a AI system. As long as it meets the differentiability requirements for any trademark, it usually is fine. Uh, Copyright is painful. Uh, copyright, actually, that's why this whole content authenticity initiative came up, which was saying whose copyright it is. And they are focusing on images. Is in text, it is trickier. I don't think there are very good, I would say, regulations for that yet. However, because of the way the image side or video side of things is a little farther ahead, and they are now starting to publish. I think yesterday they published something that they define as a transparency kind of definition, or JSON like structured format saying image transparency, which actually says how and where and which model and how that image was created, what data and things like that. So I'm sure probably over the next few months or about a year from now, you will have some similar provenance and copyright related things for text. For right now, at this point, we don't. For images, we are starting to see those. And actually people are using them in their commercial solutions. The next question basically says, what if I use a PDF of a book to train an algorithm to get certain outcome? Can it be considered as copyright infringement? No, it can't, unless you start using the same language. So you have to make sure your model is not mimicking. So, and that is the basic thing. So you anyway want to always make sure your model is not mimicking, as well as the model is not hallucinating. Second part of your question is, what if I purchase a soft copy of the book and train there? First part of the question, I assumed you have the right to use that book. That is the part, right? So irrespective of whether you train your book, your model on that data or not, you should have the right to use that book. So it cannot ideally be scraped. So it has to be open data in that sense. That nuance of what if you purchase the book and train the model, generally, I would still go by the fact that it should not mimic and it should not hallucinate, which is it should not make up the things and attribute it back to the model, to the book, nor should it completely assume that this model is creating new content which is exactly picked up from the book without attributing it. So the whole idea of transparency and accountability is the ability for these models and systems to go back to the original context and say where it came from. Moment you start doing that, it is like you're referring to its source, right? So you are not doing any infringement. But if you don't refer to those sources, then there will be a problem. So, yeah, I think if you're planning to use this in production, maybe good to get dig a little deeper. So at least so far, the stuff that I have tried to use in production, at least I knew that there was right to use that data. So maybe some kind of consent, if you have access to the source of that book, will be a good idea. Sumit, do you want to continue?
Yeah, so I think uh, yeah, towards the end of this particular webinar, uh, as usual, incredible insights, Niyati. I hope this will help the audience get a new perspective when they see any AI-enabled technology platform here on, either to design, build, or use. Right. If anyone has any more questions, probably we can open it up. Probably I had one, Niyati, wherein you spoke about data not being for cross-selling, right? So when it comes to building specific models for cross-selling, what is the ethical way to go about it?
It's a hard question. So it's when you say cross-selling, I can definitely cross-sell within my customers' data, assuming I have asked for that consent, and that's how I'm structured as an organization.
Mhm.
Uh, for example, Google says it owns our data. Google upfront says they own our data, and they use it for everything and everything, anything, right? So all their Google indexes include all the data they have access to, or we have given them access to. Companies like Adobe, for example, or I think Microsoft also to some extent, say the user's data is their own, which means they are restricting their own software, um, what do you say, teams from using cross-customer data. So that's one thing. Now cross-selling can potentially actually be initiated by using some publicly available anonymized data, where going back, or aggregated data where you cannot trace back to an individual. So, for example, there are these agencies, right? Advertising agencies, branding agencies, all of those publish reports and analytics on aggregate data on behavior of cohorts, behavior of individuals, behavior of whatever demographics, usage patterns, all of that. Moment you aggregate it, you are again hiding the individuality. So you are not taking anyone's data. You are just publishing statistics. So moment you do that, you can start using that for cross-selling. But let's say I am Tata and I know someone bought sugar, I may want to cross-sell salt. All e-commerce, all of these folks out there do that, and then which is fine, which is recommendation, right? And there you are cross-selling not based on the identity, you are cross-selling based on the clicks and the usage. So that is not user ID necessarily. Even there you can argue, or you can give me an example of Facebook where if I actually go and search for X right now, I'm sure next time I log into Facebook or Insta, I will see that X pop up. So
Right.
Meta is okay doing that, and actually Meta unknowingly all of us approve Meta to do that, and
Hmm.
that's for a lot of people who are skeptical about technology use, and there are tons of them even today. They will never approve Meta to kind of do all
Hmm.
of kind of take in any user generated data that's coming in. So
Right.
yeah, I mean, there are workarounds, but kind of the guideline that I was talking about was very specific to if I don't have mitigation techniques, I don't have masking, I don't have anonymization, all of that, and if I don't have aggregation, in that case, I can't take X's data and use it for Y. So,
Yeah, makes sense. Makes sense. Nice. I think we are just in time to conclude this rather interesting webinar. I hope this discussion was worth everyone's time, that the audience has taken away valuable insights, and they'll apply the same when they are either designing, building, testing, deploying, using any AI-enabled technology platform here on. So once again, thank you everyone for your time, and hope to see everyone around again in our subsequent webinars. Good evening and have a wonderful weekend. Thank you.
thanks. Bye bye.